time to do some more D3D11 triangle stuff. So what do we got? We've got a vertex shader. So we need to let the graphics API know that we have it. So we have the compiled version of it. So let's see here. Let's open the reference. What is that? Which is that, yeah. Okay, so the actual function to create a shader is this one. It's on the device, so it's create vertex shader. Just pointer size and then, you know, other things. So create let's see. Shader bytecode, length, so it's on the device, yeah. Pointer size, class linkage. Okay. And this is the output to like the handle. Alright. Okay. So device create vertex shader. So it's well, it's LPV table. Create vertex shader. Yeah. Create vertex shader. Shader bytecode. So we don't need anything else that's here, presumably. Yeah, pretty much don't. Yeah, well, yeah, we already have the compiled everything. So create vertex, create pixel, and then just the input layout, and we don't need anything else. Create vertex shader. Device pointer length. What is it? Pointer. Device pointer length. Then like null, and then we've got the return value, which is going to be v shader, which we have to save. ID3D11 vertex shader. Is that what it's called? ID3D11 vertex shader. Yes. And it's a pointer. What? Man, this formatting is just something else. Yeah, that works. I'm guessing this returns an H result, right? Yeah, H result. So where are we? Swap chain sort of ends here, then it's vertex buffer. Okay, so I gotta make sure that this is actually working. This janky system of precompiling it, including it. Well, it seems to have worked. Don't think we have any errors. Not our errors. So that's good. Yeah, alright. So that's vertex shader. We also need pixel shader, which is like that, but instead of shader VS, it's going to be shader PS, and PS is the entry point right here. Compilation failed. Oh yeah. So this is PS 1.5. Yeah. Alright, so let's see here. There's our shader. Okay, so ignoring both of those. So this vertex began. Oh god. Well, really, this vertex here becomes pixel. Okay, except this has to be P shader. And both of these need to be released. Release. Yeah. Okay, so we're not including that. Now we are. Okay, we have the shaders. Presumably, we have the shaders. Okay, no errors. No errors. Correct. Okay. Okay, we have the shaders. Now, what's next? Yep, so that's just shaders. Yeah, that's we don't need the buffer. We don't need the texture for now. Don't need the sampler. Don't need to blend anything. Rasterizer. Now rasterizer we do need. Create rasterizer state. So that's on the device. Create rasterizer state. So device. Oh wait, we're not done here. We need input description. Input layout rather. Yeah, which is that. Okay, what is this? D3D11 input element desk. Yeah. Well, I mean, here we only have one element, right? Which is let's see what fields do we have in there. Semantic name, semantic index, format, input slot, aligned byte offset. Okay, so semantic name, semantic index. It's position. Yeah, so semantic name, semantic index. format, the XGI format. It's R32, G32 float. Yeah. Semantic name, semantic index, format, input slot, which is also 0. Okay, so semantic index for the element modifies, semantic index modifies the semantic with an integer index number. More than one element with the same semantic. There are 4 components, each with the same semantic name. Each of the matrix. However, each of the 4 components would have a different semantic index. So I see. So if we had 2 positions. So that explains it, yeah. And then we have input slot. Defines the input assembler input slot. And input slot is just 0 for all of them. And, well, byte offset from the start of the vertex up to. Okay. Which is going to just be 0. Right? Align byte offset is also 0. Input slot class, as in like per vertex or per instance. D3D11 input per vertex data. Instance data step rate. The number of instances to draw using the same per instance data before advancing the buffer by 1 element. So that's 0. Okay, so this is an array. Really? Like we have to format it this way? Okay. Does that even compile? Yes. Okay. I mean, why not, right? I mean, this is awful. Why would you want to format it this way? Just one line it. It's way better. Yeah, we don't have anything else. So now we just need to create the input layout, which is also on device. Yeah, device LP table input layout. Device desk. Desk pointer, desk length, the shader to which specifically the binary version of the shader looks like. So it's not this created shader, no, it's the buffer where it is. So it's that. and return value. And this layout is D3D input layout. And we need to release it. Encoded signature doesn't match specified size. Well, at least we stopped here. It doesn't match specified size. Yeah, I think let's see, let's look at the description. Okay, where would that go? No, not here. All right. So description doesn't match size. For vertex 0. Pointer to the first element. Okay, well, we know this works because the shaders were created, so this part is fine. Oh wait, it's PS length. This is PS length. Yeah. Was that the problem? Yes. We have a layout now as well. So now we can have a rasterizer. A U-buffer, no. Texture, no. Sampler, no. Blend, no. Rasterizer, yes. D3D11 rasterizer desk. Is it like one of those all caps? Yeah. No, actually, this one isn't. Wait, is it? No, it is. Okay, look. There. Rasterizer desk. I have to look that up. Fill mode, cal mode. Alright. Oh god. Fill mode. Yeah, we want like solid, right? There's only two of them anyway. So that's the fill. Cull mode. We don't want to cull anything. Cull none. Front counterclockwise, I don't care. Depth bias. I don't care. Depth bias clamp. I don't really care about that either. Slope scale depth bias. Depth clip enable, no. Scissor enable, no. Multi-sample enable. Anti-alias inline enable, no, we don't need any of this. And what? Just create rasterizer state on the device. Okay. Device, desk, I'm guessing, and rasterizer state. And rasterizer is gonna be D3D11 rasterizer state. We have a rasterizer now. We don't need depth, and we're kind of already doing all of this. Okay, now we just need to set things, so we're doing that. So that is the viewport. Okay, clear on the target view, I don't need the depth, we don't need that. Rotation matrix, input assembler. Okay, so context, set IA, set input layout. So in draw, we need to go and what is this? This would be IA set input layout. Context layout. Does this stuff return anything? Like H result or whatever? No? Void, it never fails. Oh my god. Set primitive topology. Is it IA set primitive topology context, and then just D3D11 primitive topology triangle list. Yeah. Stride offset stride is, I mean, it's float. Like, is that allowed? Yes. What's this error? Primary expression expected. Yeah, but this compiles though. What are you talking about? What? Man, the language server is not that good, huh? It's not that good, huh? Alright. Stride, offset, and then we need to just set vertex buffer. Over set vertex buffers. Vertex buffers context. Start of the array, amount of buffers, I think. Let's see. Set vertex buffers. Start slot, number of buffers, then where the list starts, which is v buffer, then stride and offset. So it's just the size of one. Context, IA set vertex buffers. I mean, really what this is like that, right? So we want arrays here. And then, and even buffers like D3D11 vertex buffer pointer array v buffer. It's something like this. I mean, it is an array of those things, so like, what do you want me to do? It's an array of point. How do you even do an array of pointers? Int star array equals null. Does that work? No. No, that is how you do it. Well, it's some kind of vertex. Something. Well, it's just buffer. That's right. There's no distinction. Format. Maybe I should just turn the formatter off. This is ridiculous what it's doing. Can this thing also never fail? Void, yeah, evidently. If you supply wrong data to it, I guess it just succeeds anyway. Set, okay, set shader. That's on the context as well. VS set shader. does this take? Class instances. Each interface used by... Yeah, apparently we don't have any of those. VS set shader. We don't have constant buffers. Rasterizer stage. RS set viewports. In the context. RS set viewports. Context. And then RS set state. Then it's PS set samplers. Well, we don't have any samplers. All shader resources. We only have the shader. So this is PS set shader, P shader. OM blend state, no, render target. RT view. OM render targets. So context. OM, what is it? Set render targets. What am I doing? Control B does that, okay. Number of views. Well, that's an optional. I see, so the first one's like an array. So that's one RT view and then just null for depth. Context. Okay, so we set the render targets. Now, do we need anything else? No, we just have context draw. Three vertices. Context draw that one, yeah. Vertex count, start vertex location. Yeah, so three vertices, start location 0. Okay, so let's see. Well, it drew something. Now it's orange. I mean, it's orange everywhere, and not just where it's supposed to be, but it's definitely working, kind of. Now to debug this, we're gonna need render doc. Yeah. Latest stable zip. render doc UI. Don't just okay. Pin. Okay. Click here to set up Vulkan capture. Yes. Tools, settings. Why is it so tiny? Dark. Yes. Global font scale. Restart required, except apparently it isn't. And why doesn't it respect the display? Scaling settings. Executable path. Okay, well this we don't need. What we need is an executable path, which is just going to be that. Path working directory is going to be that. Launch. F12. Close. Alright, well, let's see. We want mesh viewer. Okay, well, I mean, that is the triangle I expected to see. Why is everything orange? And why is this so big? Relative to the rest of the UI, this is just gigantic. Okay, reset. Yeah, this is the triangle I defined. For some reason, everything's orange though on the actual screen. Windows security, yeah, just allow access. Why is that? Is it because of the scaling or something? It could be. Because like, yeah, this is fine. This is fine. Like, it's like, wait, are we looking at the inside of it or something? Okay, well, let's find out. Yeah, I wonder how well it will react to the show desktop. All right. Okay, let's just relaunch everything because it doesn't adjust to that very well. Save this caption, no. There is render doc. Let's make it in line with everything else. Yeah. Launch. Load last. Launch. Okay, well no, it is that small. No matter what the scaling is. Mesh viewer. Draw. Yep. Yep, that's the triangle. Oh. So in is fine, but it's the out that's it's not fine. It's really big. It's really big. Controls, arc ball, I don't know. Can I zoom out? I would like to zoom out. um, yeah, for some reason minus 1 is like way over there. So yeah, we are. Why can't I zoom out? So we are looking at the thing that's just all orange. Because for some reason the output, like what's wrong with this output? I don't get it. 0, minus 1, 0, 1, minus 1, 1, minus 1. Yeah, how does that translate to like everything being orange? Yeah, I don't get it. It just stretches out way beyond the screen. Oh wait. Oh yeah, it's gonna divide by one of those. Well, actually, we need to watch through the terminal. Of course. Shader. Like it's gonna divide. Let's actually see. Let's remind ourselves what. No, don't save that capture. Yeah, so it's the W. So whatever the Z is, it's gonna divide by its, yeah, because you're supposed to like store, yeah. Launch. Yeah, there it is. So it divided by 0 and somehow got something kind of valid. Even. Interesting. Well, there is our triangle. It is being displayed correctly. Let's commit that. Oh yeah, I remember. So the W basically stores the original Z, and it divides both X and Y by that. For perspective, which we don't really need here. Focus into primary sidebar, yeah. That's fine. That's fine. That's also fine. That's fine. Okay, well, draw a triangle. We drew a triangle successfully. Apparently we don't need this, although I'll keep that in there for now. Okay, well, that's not too bad. Formatting. Sync changes. Okay, well, that's all I have time for today. See you later.